Okay, so carrying on from the previous video, we're going to be looking at a connected particle, but now these particles are over a pulley. So a pulley is one where, I'm sure you guys have seen it before, when one particle goes down, another particle will move up, right? So they're still connected by a string. The string is still light and inextensible, meaning that the tensions and acceleration are the same, but now it's just passing over a pulley. So like the previous video, what we're going to be doing is we're going to give it some cuts and make sure that we get the right t values and then therefore find the correct acceleration. So let's look at this one here. We have particles p and q of masses k, m and 3m respectively, where k is less than 3. The particle is connected by a light inextensible string and it passes over a pulley. It's held at rest and then you let go and then the system is released from rest. After release, q descends with acceleration 1/3g. Calculate the tension in the string as q descends. So first things first, let's go about sketching this, labeling all the different forces that we do know. So we have a pulley and we have two particles and they are at the same level initially. So this is q, this is p. Q's weight is 3m, so it's going to be 3mg downwards. P is weight of kmg, we don't know the k. And once it's released, it says that q descends with acceleration 1/3. So that means it's going to go down with 1/3g, meaning that because p is connected to q, that's going to move upwards or accelerate upwards with the same acceleration 1/3g. Right, now what we need to do is give it some cuts like the previous video we looked at. So in this case, when we cut it is between the pulley and each particle. So for Q, I'm going to cut it randomly here. For P, I'm going to cut it randomly here. It doesn't really matter as long as it's in between the pulley and the particle. Now the weight is pulling down, meaning it's a pulling force, it's a tension force, so the tensions inside the string are going to be pointing towards each other like here, and the same situation here, T and T like this. Now what we can do now is look at each particle separately. So for Q, we're going to be resolving downwards as positive, but it's going to accelerate downwards, right? So F is ma. So we're going to have that 3mg minus t is equal to mass, which is 3m times the acceleration, which is 1/3g. So we're going to get 3mg minus t is equal to mg. So t is going to be equal to 2mg newtons, like so. Show that k is 1.5. So for B, k is the mass of the particle P. So let's look at for P. And now let's resolve, because P is going to accelerate upwards, we're going to go upwards as positive and do F is ma again. So in this case, we have the tension, T going upwards, positive, minus the weight acting downwards, so minus kmg. That's equal to the mass, which is km times acceleration, which is the same acceleration as P, Q because they're connected, right? So 1/3g. So T we worked out in part A for Q is the same value, so that's 2mg. So we're going to have 2mg minus kmg is equal to k/3mg. 2mg is equal to 4k/3mg. So k, you get a value of 1.5 if you work this out. C, state how you use the information that the pulley is smooth. So the pulley is smooth in mechanics. When it says smooth, it just means there's no friction. Okay, so that means if the string is going over the pulley, there's no friction caused by the pulley. Right, after descending 1.8 seconds, the particle Q reaches the plane. It is immediately brought to rest by the impact with the plane. The initial distance between P and the pulley is such that in the subsequent motion, P does not reach the pulley. Show the greatest height in meters reached by P above the plane is 1.26g. Okay, so this is a completely new question, so we need to draw a new diagram. So we have a pulley. Okay, so now the particle Q has now reached the floor, like here. Okay, and that means that P has moved a certain distance above. So let's say initially they were at this position here, right? Because they were at the same position initially. Okay, so Q's reached the floor and P has reached a certain distance, and these distances here should be the same, right? Because they're both connected by the same string. Right, what do we know? So it takes 1.8 seconds to reach it, and so they want to work out the highest motion of P. You might imagine, well, the highest distance, right, is just x, right? Because it's moved the same distance. However, the important thing to note is that when Q hits the ground, it's hit it with some velocity, which means that P has also got some velocity when Q hits the ground. So after Q hits the ground, what's going to happen to P is now it's going to still move up and then come back down again to this initial position. So it's going to move up to a certain extra height that's called this height h. And in this motion, what we can say is this is actually a motion of free fall. It's being accelerated and decelerated by gravity itself, meaning that we're going to be using a Suvat equation for later on. But first things first, let's work out this x here. So we know for for Q, let's work out the SUVAT, so SUVAT. It says S, let's call this X, U is initially 0, acceleration is 1/3g, and time it took 1.8 seconds. So to work out S, I can use the equation S is ut plus half at squared. So X we have U is 0, so half times 1/3g times 1.8 squared. So X we get a distance of 5.292 meters. Alright, so that's the distance X. So Q has moved down by a distance of 5.292, P has moved up by a distance of 5.292. But as we said, at that distance, P still has some velocity, right? So what we need to do now is actually work out this V value here. But this is the velocity at which Q hits the ground, right? Meaning it's the same velocity at which P moves up. So we can work that out. So we can say that V, we can use any equation. So V squared is U squared plus 2AS. Let's use this one here. And V, we should get a value of 5.88 meters per second. So at the point when Q hits the ground, P has a velocity of 5.88, like this. Now I'm going to look at the particle P, so for P. And once again, we're going to be looking at SUVAT, S-U-V-A-T. So we're trying to find the extra distance it reaches up, so S will be equal H. U is now actually going to be the V of the previous question, or previous part we worked out, right? That's the initial velocity, so 5.88. We know from looking at vertical resolving that the highest velocity will be when the final velocity V will be 0. Now A is no longer going to be the 1/3g from part A, because now it's no longer connected, but Q is no longer pulling it, it's just acceleration of the G value, which is going to decelerate it. So A is going to be negative G like this, and T we don't have to work out. Using any SUVAT equation, you should get that H is going to be equal to 1.764 meters. So that means that P is going to travel an extra 1.764 after Q's hit the ground. Now they want the total height of above the ground, so they want this total height here. So that total height is going to be the H plus this X distance here, plus the X distance down here as well. So it's going to be H plus 2X. And if you calculate that, you should get a value of 12.3 meters like so. So this is quite a slightly more difficult question because we're using SUVAT rather than forces. But as you can see, the way we link different parts of the motion is by the velocities, because the final velocity will be the initial velocity of the next motion. A common question, which I haven't asked in this particular example, but a common question that does come up is they say, what is the force on the pulley? This is a very common question, a 1 mark, 2 mark question that does come up regularly in the exam. So what they mean by this is, in this pulley here, we have the 2 tension forces acting downwards like this here, right? So they're asking us, what force does this pulley feel? Well, this force is actually going to be equal to this F here. And so in this configuration, F is just going to be equal to 2T. So for this example here, the T value we got was 2 mg, right? So if they were asking the force on the pulley for this example, it would just be 2 times 2 mg, which is equal to 4 mg newtons. And this is the case for this particular configuration. Sometimes the pulley might be on the edge of a table like here, with one particle hanging off the edge and one particle on the table, okay? So for this kind of question, there's TT here. If they ask for the force on the pulley, then what they're asking for is this force here. And the way we work out that force is just Pythagoras, because F squared is T squared plus T squared. So F is just going to be equal to the square root of 2T squared, like this. So it just depends upon what the pulley looks like, where the pulley is in relative to the particles. Okay, let's try this one here. So we have a box P of mass 2.5 kilograms rests on a rough horizontal table and is attached to one end of a light inextensible string. The string passes over a small pulley. This is now at the edge of the table. And there's a particle Q on the edge of mass 1.5 g. The magnitude of the frictional force between P and the table is K newtons, and the system is released from rest with the string taut. After release, Q descends a distance of 0.8 meters in 0.75 seconds. So first things first, let's do a force diagram. So now the pulley is on the edge. We have particle Q, it's got a weight of 1.5 g. And then we have a particle of P, that's got a weight of 2.5 g, like so. Now it's a rough table, meaning it's friction, and they say the friction in this case is K newtons, so K is going to be in the opposite direction because P is going to want to move right. And therefore now we can do some cuts, so we're going to have a cut here, and we're going to have a cut here. it's still a tension force, right? The weight is putting down, so the tension force, the T values are going to be pointing towards each other at the cut, like so here and here. Now we've done this, what we can do now is work out T and A. So they said it descends a distance of 0.8 meters in 0.75 seconds. So I can use SUVAT for this initial part here, AI, to calculate the acceleration. S, U, V, A, T. S is 0.8. Initially at rest 0, time is 0.75. We're trying to find this S. I can use V squared as U squared plus 2AS. And if I plug it in, you should get a value of A is 2.84 meters per second squared. So this initial part is just using SUVAT. Right, B, show that the tension in the string is 10.4 newtons. So what I'm going to do now is I'm going to do resolving for each particle. So let's look at Q. So for Q, it's accelerating downwards, right? So I'm going to go down as positive. F is MA. Right, the forces I have is 1.5 G acting downwards, with tension going upwards, so minus T is equal to 1.5 times A. A we found out from part A as 2.84. And if you do the calculation, you get the value of the T is 10.4 as they asked. Part 3, find the value of K. So for K, what I have to do now is look at the particle P, this particle here. So for P, I'm going to be resolving going to the right as positive, because P is going to move right, accelerate right. So F is MA. So what forces do I have? Well, this tension pulling it right and I have the K newtons pulling it left. It's going to be T minus K is equal to the weight or the mass of the, which is 2.5 times the acceleration. This is connected to the same acceleration as before, 2.84. T, if I plug in as 10.4 as T, then you should get a K value of 3.3 newtons like this. So you can see here, even though the pulley is on the edge of the table, it's still the same concept. We're still cutting it twice. Make sure the T values are the same or pointing towards the cut, and then sort of creating two different equations for each particle. As you said, they haven't asked it in this one here, but they might ask, as I said before, the force acting on this particular pulley, because it's on the edge of the table, that we know that F is going to be the square root of 2T squared. So T, which we found as earlier as 10.4, so 2 times 10.4 squared. So the force on this particular pulley will be 14.7 if they did ask you for this particular question.